What's up, everybody? You guys are welcome to another exciting edition of our data analysis class. So today I'm going to be giving you guys some few tips here and there because we're officially done with the month 2 of our data analysis hackathon. If you take a look at what we've been doing so far, we've done the foundation of data analysis where we covered the basic foundation in Excel and everything, and then in month 2, which is the intermediate analysis, where we're deepening our data manipulations and visualization skills with Python. We've covered the basic programming concepts in Python, and then we've done some data cleaning, and we've handled, I believe by now most of you guys can be able to handle missing values and outliers. And we've done some data visualization where we used matplotlib and created some plots, right? And then we also covered some advanced visualization using Seaborn, where we did some scatter plots. We haven't explicitly covered the heat maps, which I believe I'm going to be showing you guys today, which is the essence of this class. And then if you take a look at our session, I believe, advanced pandas, we've already done grouping, but we haven't done margin, and we haven't done normalization and scaling using NumPy. Though this normalization and scaling is not actually practical to be doing it now, I was actually thinking about pushing this, maybe taking this normalization and scaling to the part of the machine learning side. But don't worry, maybe if we have enough time today, I'm going to be showing you guys the basic normalization and scaling, what are they and why we even use them. So without any further ado, let's just dive right into our notebook. I'm just going to go ahead and then increase the font size a little bit. Let me increase the font size so that you guys can be able to see clearly. Just go to settings, theme, and increase code font size. Okay, I'm going to increase the UI font size as well. So without any further delay, I'm going to be working with the tips dataset. The reason why we're working with this dataset is readily available for you guys. There's no need of it sharing any dataset with you guys. So let me just go ahead and import our dataset. Import libraries and datasets. Let me just push this keyboard. Beautiful. So I believe by now you guys know how to import these things. Import pandas as PD. Import matplotlib .pyplot as plt, and then finally we import Seaborn as what? SNS. Cool. I'm just going to go ahead and click on Shift Enter. If you do not see any error, that means it's successfully imported. Or you can just come below the imports and print import successful, right? Something like that. So if the code reaches the import successful side, that means your import is successful. Beautiful. So now the next thing to do is to go ahead and import our dataset, right? So we've already imported Seaborn. So I'm just going to name the dataset tips because we've been naming our datasets DF. Let me just change the variable name because some people think that you can only name your you can only save your dataset to the DF variable. No, variable names can be anything, just like we did in a Python crash course. So I'm just going to name the variable tips now, and then it's going to be sns.load dataset, and the name of the dataset we're going to be loading is the tips dataset. So let's display the dataset. So print, or just say tips.head, which is going to give us a nice display. Very good. So now we have the tips dataset. For the sake of those people that don't know anything about this dataset, let me just go ahead and tell you guys something little about this tips dataset. So the tips dataset has some numeric and categorical values. So we have the total bill, which is the total cost of a meal, and then we have the tip, which is a tip given to the waiter. For example, you're doing your boy good now, so you're doing your waiter good, so maybe you're impressed with something, the waiter is nice, this and that, and then you're giving him tip, as simple as that. And then the sex is self-explanatory. I'm not going to be talking about that. Smoker is self-explanatory, is whether or not our customer is a smoker or not. And then the day, and then the time, is it dinner, lunch, breakfast, whatever, and then the size of the people at the table, as simple as that. So today I'm going to be talking about the log and the iLog, because we've used the log and the iLog because but something came over me. I did not cover the advanced log and iLog for you guys, and we are literally doing intermediate to advanced data analysis. So today I'm just going to be showing you guys how to use the log and the iLog. So the log is basically used is a label-based selection, which is used to select data using column names or row labels. Column names or row labels. So, for example, let's say we're trying to get all records where the meal happened on. I'm doing it very fast because there's no enough time on Sunday. So. Okay, tips. The name of our data set is tips. Beautiful. Tips. Okay, so tips dot log, and then open your square bracket and then close your square bracket. So we're saying tips dot log. So I'm going to be using the column. So I'm going to be using the column name to select data set based on the columns, right? You can either use the column names or the row labels to select your data set. So let's go ahead and select. Use the column name. So the columns I want to select is that inside the tips data set, I want the day. I want to select the day column where it's equals to what? Sunday. Because if you take a look at the requirements, we want to select all records where the meal happened on Sunday. So I'm going to use the log, tips log, and then select the tips day column whereby the day is Sunday, and then I'm just going to go ahead and close my square bracket, and after that I'll come and assign this subset of this data to a variable called Sunday meal, something like that. Then assign my equal sign. So now if I go ahead and then print out this code, for example, Sunday meals, yeah, beautiful. So we get a subset of the data whereby all the meals happened on Sunday. As you can see, it's obvious. Sunday meal, Sunday. Boom, that's amazing. So and you can use the log to get a column specific data. For example, if you take a look at this, we're just getting the entire data set. Please pay attention here. We're using the log to get the entire data set. So there's another parameter that we can pass to these tips, because for example, there's a comma here. If you add a comma here, it accepts a second parameter. Just like during our list, we do something like this. For example, fruits. When we created the fruits, so the first item, we use this type of syntax to slice our list, right? So you can do the same thing in pandas. You can also give another parameter to this log, because now we are getting the entire the entire columns. Let's say, for example, we want only total bill and then maybe smoker or size. So how can we do that? Well, that's literally simple. So for example, let's have a business problem whereby, for example, we want to get Sunday, let me think, Sunday, like, okay, Sunday transactions, because I want the transaction column with only total bill and tip columns. You see, now our manager is telling us that he wants the Sunday transaction with only total bill and tips column. So now our manager is explicitly telling us that he needs only the columns total bill and tips. So how do we do that? So we can use the log. We can just reference our data set, which is tips data set, and then I want to select the day, because he explicitly say, or she explicitly say, that she wants the data set for Sunday. Okay, let's get a subset of the data whereby the day is Sunday. We use the comparison operator to check for Sunday. And then very good, now we are done with the first part. And then the second parameter that this, sorry, I made a mistake here, tips.log, tips day is Sunday, comma, the second parameter is always for the columns. Now if you leave the data set like this, and then if I go ahead and run this column, I'm just gonna get this a subset of the data set whereby the day is Sunday. Beautiful. So but I want to add a second parameter. I don't want the entire columns, right? I don't want the entire column, so I'm just gonna come here and then add a comma, and then just the name of the columns. So the name of the column explicitly stated that we want the total bill and the tips column, right? So that as simple as I just go ahead and say tips, total bill, total underscore bill, because that's the name of the column, and then comma, and then the second column that our manager wants is the tip column. Simple as that. So go ahead and close your square bracket, and then if you run the code, you get the Sunday sales for, you get the total bill and the tips column, sales made on Sunday. For example, if you take a look at the output, we have the total bill for Sundays, and then we have the tip for Sunday as well. So if you want to verify, yeah, beautiful. So if you want to verify this, just go ahead and then grab the day as well, comma, day. So this is going to add, for example, just to verify that we're getting the data set for Sunday. So as you can see now, we are having Sunday. This verifies that we are getting the total bill and the tip for Sundays. Amazing. So let's jump right to the next part. We also have iLog, right? Let me just go ahead and add, maybe let me beautify this. Let me just beautify this a little bit. I'm just going to add a row at the top, and then I'm going to make this a markdown, and then I'm just going to say using log, right? I believe this heading is nice, right? Or let me see, well, let me just say .log, when I'm close square bracket, something like label base selection, something like that's beautiful. .log label base selection. But let me just go ahead and edit that. Let me make the heading a little bit bigger. Oh, what is happening? Is it not markdown? Yeah, it's markdown. Okay, then why is the heading not bold enough? Yeah, now it's bold enough, I believe. Yeah, cool. So label based selection, right? So the next thing I want to do is I want to show you guys, I hope time permits because I'm in a haste today. So I want to show you guys position based selection. So .ilog, if you want to learn markdown, I'm going to give you guys a crash course. Just go ahead and point that out. Markdown is very beautiful. So position based selection, right? Beautiful. So .ilog is position based selection. So it selects data using the index position, using the index, right? The index position. So index literally means numeric. So this is a label base, right? For the log, it's a label base whereby we're just using the row labels, right, or the column labels. But for the ilog, is index based. For example, just the I believe this this first I basically means index. I'm not sure, I'm just guessing, right? But it's self-explanatory. The naming conventions in pandas are amazing. So I'm going to be using the ilog to select data using numerical index position. So let's take a look at a real world scenario. For example, our manager asks us to select the first 10 rows, something like that. So how do we do that? So I'm just gonna do tips.log, tips.ilog, sorry, and then for the columns, I want from 0 to 10. if you remember during our list slicing class, we said if you omit the first value, it's gonna assume that you're starting from the beginning, right? Okay, we're gonna be omitting the first value, and then you see that's the reason why we covered list slicing and indices before diving into pandas. So I'm omitting the first, which is 0. I just want to begin from the starting point, and then for the ending point, I want the 10th row, right? So I'm just going to go ahead and save this to a variable, something like first 10 orders, something like that. Okay, if I go ahead and say first 10 orders, yeah, beautiful. So now we're getting the first 10 orders. For example, you see the index began from 0 to 9, as beautiful as that. So this is how you use the ilog to get. So for example, okay, what if we want to get some specific columns, right? What if we want to get something like anything, okay, the first 10 rows and the first let's say for example no, let's do 3. Okay, the first 3 columns using the ilog, right? So tips.ilog is actually very simple if you paid attention during the list slicing class. Okay, tips.ilog, for the row I want from the beginning to the 10th, comma, and then our manager explicitly told us that he wants the first 10 rows and then the 3 columns. So I want the columns to be from the beginning to the 3rd. As simple as that. And then I'm just going to go ahead. So if you take a look at the log, the first parameter that it accepts is for the row, and then the second parameter that it accepts is for the columns. Pay attention to that, please. So I'm just going to go ahead and say subset data, something like that. So now if I go ahead and then show my subset data, I get, yeah, beautiful, we get the first 10, right? And then the first 3 rows, the first 3 columns. If you take a look at the data, if you go up, the first 3 columns, it began in total bills, tips, and then sex. So beautiful, we are getting the same thing here, right? We're getting the total bill, the tip, and the sex as well. So for the rows, we are having the first 10 rows, and for the columns, we are having the first 3 columns. Amazing. So now we are done with I believe by now you guys are confident with the log and ilog. So there's one amazing thing that I want to show you guys before we go on this holiday, which is so handy. I want to show you guys the query. For example, whenever we're selecting a subset of a data, we are using something like this. We're saying tips.log, and then we are saying tips again. So we're using like double square brackets to get a subset of our data. But if you guys are familiar with SQL or something like that, which is a structured query language, which is a language used to communicate with a database, and you're going to be familiar with this. So this is simple query language inside pandas, which allows you to get subset of your data using plain English and then some maybe logical, some arithmetic operators. Amazing. So let me just go ahead and add the markdown. Let me just change this cell to a markdown, something like this, and then I'm just going to add the query, which is the SQL like fill sharing. Yeah, I believe this is correct, right? We don't care about the English, we only care about the code. So let's have a real world example of that. For example, let's say, for example, I want to see the high spenders on the weekends. Let's say, for example, we want to analyze, we want to get high spenders on weekends. Yeah, the big boys and the big girls, the high spenders. How do we do that? For example, okay, let's reference the tips dataset dot query. Tips is the name of our data set, and then dot query, right? We're using the dot query function on our tips data set, and then we can simply just go ahead and write our query between 2 single or double quotes. So I want the tip column, I want the tip that is greater than 5, and I'm talking about the high spenders, right? Yeah, the high spenders is, so I have to reference the total bill because that is where the money is located. So the total bill column that is greater than $20. Nope, $20 is not a high spender. Let's do something like $30, and maybe let's check. Let's see if smokers pay more money, spend more money, and smoker is equal to something like no. And then I'm just going to go ahead and then save this to a variable called high spenders. Very good. Boom, we're getting an error. So it says keyword not valid. Okay, in the query there's a keyword that's not valid. Okay, let's go ahead and check our query. What is not valid? High spenders is correct. We're referencing the tips data set, and we're using the query, which is correct. Okay, total bill greater than 30, and smoker is equals. Okay, yeah, we're using the assignment operator instead of using the comparison operator, which is this. Boom. So the reason why I'm fast with this detecting errors is because of the experience. Don't worry, if you're having errors and if you're finding it difficult to fix your errors, don't worry, just practice more. With time you're gonna get there, right? So if I go ahead and then print my high spenders, okay, I am having no data set. Why is that? Okay, high spenders, total bill greater than $30, and then smoker is equal to no. All right, is that because $30 is more or something like that? Okay, let's change the smoker to yes and see. Oh, all the smokers are spending above $30. So now we are having the smokers, the total bill above 30, and smoker is yes. Okay, now smokers seem to be spending more money in our data set. I don't know why is that. You people should help me answer that. So let me just go ahead and do another example so that you guys will be familiar. If you take a look at the query, it's literally very simple, right? We're just saying total bill, which is the name of the column, greater than 30, and smoker is yes, right? You see, but there's nothing like tips, square bracket, double square bracket. No, we're just using the query just like in a database, and then we're getting a subset of our data, as simple as that, right? Beautiful. Let's continue. So let me just cite another example so that it's going to be easy guys to follow. For example, let's say we want something like let's say we want to see if we want to see the tips for weekends, right? Get the tips for, should we do weekdays? No, let's just do weekends, because I believe people spend more money on the weekends. Yeah. So for example, let's reference the tips data set dot query. Open our single or double quote. Sorry for that. Open our single or double quote because we are working with a string, and then the tip. I want the tip that is greater than, let's say, 6, and the day. Let me use the in operator. I believe we've done the in operator when we are doing the list in our Python crash course. Day in Saturday, comma, and Sunday, because that's basically the weekend, right? Sunday. So let me just go ahead and run that. Yeah, and then I'm just going to go ahead and save this to high tippers, something like that. High tippers, yeah, high tippers. I believe it makes sense, right? So if I go ahead and run the code, okay, I made a mistake. So if I go ahead and print high underscore tippers, I get this, right? Very good. So people gave a tip of $7. Beautiful. People are giving a tip of $6, even $10. Wow, these people are rich. Beautiful. So now we know how to use the query. Okay, please, I recommend if you want to learn more about the query, I don't recommend using any language model, maybe ChatGPT, Gemini, Grok, or BAT. Please go to the Pandas documentation, which is a well-written documentation. Go there and then look for the query documentation. I believe you're going to get so much knowledge from there. Yeah. So as an instructor, we don't show you everything. We just show you the useful functions, and then it's left for you to go and do your research and then learn more and then get an in-depth explanation, right? So the next thing that I want to talk about is let me take a look at the outline. Is margin, right? We've done grouping already. Margin, beautiful. So let me just go ahead and do the margin as quickly as possible. Yeah, let's do the margin. Let me just show you the margin. Let me make this a markdown. Yep. Margin, which is dot merge. Dot merge. Combining is basically combining, as the name implies, it's plain English. Combining data frames. Oh, I made a mistake. Combining data frames. What's wrong with my typing today? Beautiful. So the match is used to join two data sets together. Let nobody confuse you. Beautiful. Just join two data sets together. So okay, let me see if I can go to my whiteboard and show you something as simple as that. We're using the combine to join two data sets together. Simple as that. Let me just zoom. Combining two data sets together. For example, let's say we have a data set like this. Let's say we have name. We have a name, and then we have each, something like that. Each, boom. Name is A, second name is B, third name is C, and then first age is 1. Let's say for second age is 2, and then third age is 3. You literally, and then let's say for example you want to add a sex column. For example, you do something like sex, right? You want to do something like sex, and yeah, you want to add maybe a sex to this column, right? So you want to do something like for example, okay, maybe male, female. Yeah, we only have it's binary. Don't worry, we're working with binary. There's nothing like trans or something like that. Yeah, female again. So margin, what margin does is it merges two data sets together. For example, let's say you want to add additional, let's say this is df1, this is your first data frame, and then you have a new data frame which is df2. So you want to merge these two together so that you have a new column. As simple as that. So if you match these two together, you're definitely going to get something like name, right, age, and then sex. Because of what? Because of the margin. You've matched them together, joining two data frames together. Simple as that. And there are some parameters that it accepts. Let me see if I can. There are some parameters. Delete. Yeah. Delete. There are some parameters that this margin accepts. Why is it not deleting? Okay, let me do it manually. Okay, so there are some parameters that this accepts, right? For example, let's say you want to, for example, let's say we have this, for example, name, age, right? So for example, MC Justice, which is JS, and then Juliana, which is JL, right? These are my serious students, right? So the age is 20, 10, 30, right? For example, let's say I want to add maybe gender, maybe something like gender. Okay, I'm gonna have a gender. I'm gonna have a, let's say this is df1, this is your first data frame, and then let's say I have a new data frame which is called df2, and then I want to merge this, right? So let's say for example I'm gonna make this data frame as something like MC. It's gonna have a name, right? And then it's gonna have maybe sex, right? So the name is going to be MC Justice JS, and then Juliana, which is JL, and then the sex is going to be male, and then female. As simple as that. So the reason why we're having this is because we want to reference this column, right? We don't want to give random sex. That's why we're just having the names, and then we're having the sex, right? So you can do something like merge, which we're going to do in programmatically. So we're going to do something like merge df1 and comma df2. As simple as that. On means on which column do you want to match them. So you want to match them on the name column because the names are identical. So on is equals to what? The name column, right? And then how there's a parameter called how, which is equals to left. We just want to put it to the left side, right? Left as a string. So if you close this bracket, what you're going to get is MC 20 male. You're going to get something like Justice 10 male, and then you're going to get something like Juliana 30 female. As simple as that. So let me just go ahead and show you programmatically. Though we're going to be doing the basic match here, we're just going to be doing the basic match. Maybe I'm going to dedicate an entire day to show you guys how the match is done, because we have inner, we have outer, we have left, we have right. We have like 5 margin types, but I'm just going to focus on the simple one for the sake of time. So how does you've already seen how the margin works, so let's just go ahead and do that. For example, let's say we want to add a discount column to our data set. So how do we do? Let's create another data frame, right? Let's create another data frame, which is equals to pd dot data frame. This is used to create another data frame in pandas, right? pd.data frame. Please go ahead and read that in the pandas documentation. It's basically like a dictionary. We've already covered dictionary, right? It's like a dictionary. pd.data frame. Okay, I want the day because I want to apply discount for a specific day, like maybe on Sunday and Saturday, and then maybe the end of the week, like something like a Thursday and Friday. That's the only day that I want to apply discount to. For example, in my day as the key, and for the value, I'm going to have a list because I'm listing items. I want for the Sunday, comma, and then I want to add discount for Saturday as well, and then I also want for Thursday. Thursday, I believe Thursday is THUR, right? Yeah, I believe that's how they are named in the data set. Yeah, these are the shortcuts. If you take a look at the day column, Saturday, Sunday. Okay, let's go up and see. Let's go up and see a little bit. Yeah, we only see for Sunday. Yeah, I believe this they use the short form of the days. Thursday TUR, and I believe Friday is FRI, if I'm correct. So I'm done with the first comma. So now I have to create a discount column as the key, and then for the value I want to give a $5 discount on Saturday, and on Sunday, let me think, on Saturday I want to give like $10 discount, and maybe on Thursday I want to give like $3 discount, and then on Friday let me just give them a $7 discount, and my data frame is done. My data frame is literally done. So if I go ahead and run it, you see that I have my day, Sunday, Saturday, and Thursday, and my discount is $5, $10, $3, and $7 respectively. What happens if I remove this, the value for Friday? Let's see what will happen. We get a misbalance in the data frame, and all array must be of the same length. So whenever you're creating a data frame, the number of columns should correspond to the number of rows, please. So let's go ahead and undo that. Beautiful. Now they are corresponding. It's well balanced, right? So how do we match the tips data set with this discount? So we can literally it's very simple. We can just say tips, because that's the name of the data set, dot merge, open and close bracket, tips dot merge, right? So we want to match, tips is the name of the data set that we want to match, right? And then we want to add this. Sorry, let's save this to a variable called discounts. We literally shift enter. I'm just literally saving this data set to a variable so that I can use the variable here. I believe you guys know that by now. So I want to merge it with the discounts data sets, comma, on means, as I told you in my whiteboard, on means on what column do you want to give the discount? Okay, on the day column, because that's why I'm giving the day, on these days, on the day column, right? So on is gonna be what? Is gonna be day, comma, and then the third thing that I want to do is how, as we have seen in the whiteboard, sorry, in the blackboard, is gonna be left through the left side, and then I'm just going to save this in a variable called merged tips, right? So after that, I want to print it and see. Oh, that's amazing. So now we get our discount. As you can see, on Saturday, Sunday, and Thursday, we are having our discounts respectively. So for Sundays, we said it's $5. As you can see, Sunday we are having $5, and Saturday we are having $10, and for Thursday we are having $3. Let's verify. And for Thursday, which is this, we are having $3. So let me just go ahead and print tips.head. Like let me print like 40 rows to see if you can see many. Yeah, dinner, Saturday, Sunday. Very good. Okay, let me try something. Tips.query day equal to I hope you guys know what I'm trying to do here. Day equal to what? Monday. Okay. Yeah, I believe Monday is capital letter. Tips.query day equal Monday. Okay, we are not getting are we doing this thing correctly? Yeah, day, month. Okay. Let me do something like Saturday. Okay, yeah, we have Saturday. Okay, let me do something like Friday. Yeah, for Friday we applied the discount $7. Yeah, as you can see, $7. And let's check for Thursday to see if it's correct. Thursday. Yeah, for Thursday we added a discount of $3. Let's verify. We only having the subset of data for Thursday, which is $3, which is correct. And for Sunday, let's check for Sunday, $5. Yeah, it's $5. And let's check for yeah, we literally check for everything. So our discount is applied correctly. So this is how you match two data frames together. For example, now we have the discounts and we want to merge it with the existing data set, and then so we just call the existing data set tips.merge. We want to merge it with the discount data set, which is this on what column. We want to match them on the day column. So if the days are identical, it's going to match. If they are not identical, it's just going to fill it as a null value. How is left? As you can see, it's on the left. As simple as that. So I'm just going to leave it there. I don't want to go too deep because I'm just going to complicate things for you guys. If you guys are interested in the advanced margin, because we have a lot of the margin. We have the inner, the outer, the left and the right. So if you guys are interested in that, please notify the moderator in the chat section, and then I'm just gonna go ahead and do that. So without any further ado, let me just dive into the heat map. Heat map is very simple. So before I even write a single line of code, I want to take you guys back to my blackboard so that I'll show you guys what a heat map is, right? Yeah, so let me check my blackboard. Heat maps are very simple. They are literally so simple, right? If you get the hang of it, right? So for example, a heat map, for example, let's say we have temperatures. For example, a temperature for January, and maybe February, and then March, something like that. Yeah, right. So the temperature for January, let's say we have it in a list. For example, it's 20, 30 degrees, maybe 35, maybe 40. Let's just leave it there for example purposes, right? And then the temperature for the temperature for February is, let's say for example 45, 49. Let's say we're in Sokoto, we even go to, let's say, 43, right? And then finally, let's say we have temperature for March. Let's say we have 30, we have 16, and then maybe we have 26. As simple as that. So if we want to show a heat map of this for illustration purposes, it's going to be something like this. Let's say we have a heat map, right? And then we have something like January, and then we have February, and then we have March, right? So we're gonna have boxes like this. for January, a box like this for February, and then this third one is going to be for March. And then we're going to be dividing, since we have 3 data points, 1, 2, 3, we have 4. Okay, let's just cancel it. So we have 1, we have 2, right? Very good. So for January, we have 20. So 20 is a bit more, right? It's 20 hot. Yeah, okay. For the sake of this, I'm going to be anything above 20, I'm going to be color coding it to red, and anything below maybe below 15, I'm going to be color coding it to blue, right? And then anything in between, I'm going to be color coding it as yellow. So below 40, okay, 20 is going to be something like what, let me just give it white color. Yeah, white. Let me just give it white. Okay, 20. And then 30 degree is a bit red. Let me just give it 30 degree. And then 35 degree is also red as well. 35. So on Friday we have 45, obviously red. 49 obviously red. 43 obviously red. 30 is going to be red as well. 16 degree is going to be blue because it's colder. And then maybe 26 degree is going to be white. So this is a heat map. Basically what is happening here is that it's going to color your data to you. So this is going to be a white color. So maybe the lighter the number is going to give it maybe a lighter color, like 20 is lighter, and then 26 lighter, right? We're having a lighter color. And then as the number goes, so for example 30, the color is going to change, red color, right? Red color, red, right? It's going to be giving you different colors for different numbers. For example, the higher the number, the higher the temperature, the color is going to be red, and then the lower the temperature, the color is going to be blue, and then the mid temperature is going to be white. I could have used yellow, but I'm just using white. I don't want to be selecting my pen anyhow, right? So this is basically a heat map of temperatures, right? This is basically a heat map of temperatures. It's just mapping the numbers to colors, as simple as that. Mapping our numbers to colors. So please, if you understand this, heat maps are going to be so simple, right? So let me just keep my whiteboard, and then I'm just going to go ahead and show you programmatically how to do that. So how do we use heat maps in our data set? How? Okay, let me think about how to do that. Okay, since we already have the tips data set, let's just think about how we can use this tips data set to show. Okay, let's see if we can compute some correlations, right? We want to show some correlations. Let me just change this to Markdown. Beautiful. So how do we calculate the correlation? Okay, let's say tips.core. This is going to give you the all correlation, and then I only want correlation in numeric data set only, because it's going to if I do not include the numeric only, it's going to perform correlation for categorical columns as well. So I just want the numeric columns. If I run this, I'm going to get a table like this. So for example, as you can see, I'm just checking. See, the .core is used to check correlation, as simple as that. So in correlation measures how strongly two numerical columns are related. For the sake of beginners, correlation measures how strongly two numerical columns are related, and it ranges from -1 to 1, -1 to 1. If you can see, there's no any number in this table that is above 1, and there's no any number that is above 1. So as you can see, we have 0, we have 1.0000 and 1s. It ranges between 0 and 1, right? So for example, the total bill, if you can see, there's a 50% correlation between the total bill and the size, number of people, right? Total bill and the number of people, there's a 0.5 correlation, which is 50%, right? Correlation, right? For example, the tips, let's check the tips. Yeah, the tip and the size, 0.4% correlation, right? And the size, let's see if there's any correlation between the size and the number of tip. Okay, we have the size here and the tip. 0.4%. Very good. So, but if you take a look at this, it's so difficult to visualize, right? So let's just use the heat map to visualize this data, this table, and see if we can make more sense out of it, right? So I'm gonna be, let's check, have we imported the, yeah, we've imported the libraries. Cool. So we can just go ahead and continue. Let's rush, there's not enough time. So plt.figure, let's create a canvas. This is, we're going to just create a canvas of a size, fixed size, of a size 8 by 6. I'm just creating a canvas for the visualization, and then SNS. We are just referencing the Seaborn library, which is SNS, right? That's basically it. So SNS dot heat map, right? SNS dot heat map, right? Let's save this to a variable, please, so that we can reference it. Correlation matrix. Yeah, correlation matrix. So SNS dot heat map correlation metric. Yeah, let me just change it to matrix. Yeah, correlation matrix. We want to visualize the correlation matrix. Annotation. No, I'm going to explain all these parameters that it accept. Annotation is equal to true, and the color map, which is a C map, I want it to be cool warm, and then I want the line width, the line of the boxes, the line width to be 0.5, because that's what I basically do whenever I'm drawing my heat maps. So plt.title, I want the title of my heat map to be correlation heat map of tips. That's it. Give a descriptive name, please, so that when whoever that is reading your code is gonna know. plt.show, as simple as that. So let me see. Yeah, there's a mistake. Okay, we haven't closed the string. That was quick. Still haven't closed the string. Another error. Fixed size is not defined. Okay, plt.figure. Okay, we do not put an equal sign here. That's the reason why we're getting the error. Wow, beautiful. That's amazing. So we are getting, let me reduce the zoom size so that we can have it on a single page. Yeah, as you can see, we have a heat map, right? So how do you interpret this heat map? So let's see the correlation. Total bill. As you can see, total bill and total bill. For example, we have a total bill here. Let me see if I can annotate. Control-2. Yeah, if you can see, we have total bill here, and then we have total bill here. So total bill has a positive correlation to itself, right? 1 to 1, right? That's why it is red. That's why it is red, right? So on the second side, total bill and the tip, right? 0.6%. That's 0.6, right? Almost 100, right? How about total bill and size? Yeah, 0.6%. Sorry, 0.6. That's almost 100. That's 60, right? So if you take a look at, there's almost positive correlation between the total bill and this. The higher the total bill, sorry, the higher the number of customers, the higher the tip. As simple as that. And for example, let's take a look. The reason why this box is having red is the tip has a positive correlation to itself. Now it makes sense. It should have a positive correlation to itself because the tip and the tip have a positive correlation to each other. How about let me remove the boxes. How about the tip and total bill? Sorry, the tip and the size and tip. Size and tip. 49, 0.49. Okay, how about size and size? Positive correlation, because it has a positive correlation to itself. It makes sense, right? Okay, how about tip and size? Yeah, 0.49. Size of the customers matters, right? Okay, how about tip and total bill? 0.68. That's the correlation. Okay, how about total bill and tip? Total bill and tip, 0.68, right? Okay, how about total bill and size? 0.6, right? How about size and total bill? 0.6 correlation. Okay, how about size and tip? Okay, how about size and size? Size and size is 1. That's 100% correlation. Yeah, it has a positive correlation to itself. So I believe by now you understand. So if you take a look at the right hand side, this is a color coding. The red color indicates that it's 1, and then the almost red, somehow red, it's 0.9, and then pale is 0.8, and then maybe light blue 0.7, 0.6 is a bit darker blue, and then darker blue is 0.5. So this is how you check correlation. For example, if you take a look at this, this is dark blue, right? This is dark blue, and then this is light blue. This in the middle, that is somewhere in the middle, 0.6, somewhere in the middle, right, between total bill and the size. It makes sense now. The more the customers, the higher the bill. So there's a positive correlation. Hello guys, so while I was recording the video and I lost my microphone, so I showed you guys how to do an advanced heat map. Sorry for that. So this is why I'm re-recording this session. I lost the audio for the last part of the video. So what I did here is just I just did some advanced heat map for you guys, but unfortunately I lost the audio while recording for this part. So but I've already done that. If you take a look at this, I'm just creating a canvas. Let me just zoom a little bit further. I'm just creating a canvas, or I'm just creating a fixed size of 10 by 8, and then I'm just creating a heat map with some more parameters, right? With more parameters. So if you take a look at these parameters we are just visualizing the correlation matrix, which is just a variable that we saved here. If you take a look at it, this is the tips.core of the numeric columns only, and then we're just doing the anode through shows the correlation values inside the cell. The anode through basically shows this cell, as simple as that, the numbers in the cell, and then I've already commented this. The MTP converts this to 2 decimal place. The C map is the color of the boxes, and then the line width is self-explanatory. That's the thickness. So I was even explaining and commenting this code while I was programming it, but unfortunately I lost the audio. So I have the C bar, which is true, which is just this color bar, and then what do I have again? I have the C bar keyword arguments, the shrink, and then the aspect ratio. This is just going to alter the size of this color bar, and then we have the anode is true, the color is black. Anode is just if it's true, it's going to show the annotations. It's just going to show the annotation. And okay, we've already done anode true. I believe I'm just doing it. Okay, anode keyword argument, the color is black, and then the font weight is bold, and then the font size is 12 pixels. That's the parameters for the number for the annotation. And then we have the square. Sometimes these squares are some of the squares are going to be bigger than the others, but the square true is going to make it a perfect square. And then we have the x tick labels is true, and then the y ticks label, which is self explanatory. So and then we're just adding the PLT to the title, which is a correlation of heat map, and the font size and the font weight, and then we are just rotating the x ticks, which is this is, as you can see, we have rotated it. You can be able to rotate it to any number of degree that you want. In our case, we are rotating it to the 45 degree, and then the font size we're just changing it to 12, and then we have the y ticks, font size is 12 as well, and then we're just using PLT.show. So this is a bit advanced heat map for you guys. So this brings us to the end of this today's visualization, and we're going to be having a break. We are not going to be doing our classes until after the summer break. So please, I highly encourage you guys to go ahead and practice your data analysis skills. Go back to day one, begin from Excel, all the formulas that we did from the VLOOKUPs to for the summary statistic, cell addresses, conditional formattings, if statements in Excel. Solidify your Excel skill, then come back to where we started, pandas, right? So the Python programming videos, go ahead and watch the Python programming videos. Go ahead and relearn the Python in 24 hours, the amazing PDF that I shared with you guys. Please go ahead and read that as well, and then after you're confident with your Python programming skills, you can come back to the introductory part of pandas that we did, and then go back to the visualization video where we covered the data visualization as well, and up to this class. Please, I do encourage you guys to go back and front until you guys are strongly familiar with all these concepts and you can be able to explain it to a 10-year-old, right? So finally, data analysts are not made in a day. Consistency is a key. Consistency is not about writing 10,000 lines of code a day. Consistency is all about doing little things every day, day by day, like little things every day, not doing a magnitude of code maybe in a single day. No, consistency is all about doing a small portion of your analysis every day. So keep sharpening your Excel and Pandas skill during this break that we're going to be having, and then maybe after the summer break we're going to be diving headfirst into machine learning. So I wish you guys all the best. Stay focused and stay consistent until we meet. Goodbye. If you're having any difficulty, please do not hesitate to send it down to the moderator, and then the moderator is going to share it with me. And please, for those of you that are sending yours, for those of you that are having issues, please, whenever you're having a difficulty with your programming and with your analysis, please get a screenshot of your analysis. Show us where you're importing your data set, and then please do ensure that you're running each and every cell, and write a comment about the errors that you're having. And if possible, please, we don't even need a comment. It's possible, just we need an entire maybe a screen recording or a screenshot of your entire data set so that we can reproduce your code and then see where you're having the error. So I wish you guys all the best. See you guys after this break. Bye bye.